All right, so now we are going to start complex numbers today. Again, I hope everyone's doing okay. Let me know if you're not or if you need anything. But let's just go ahead and get right into this so that we don't waste any time. So complex numbers. Well, what is a complex number? Complex numbers are basically all the numbers. It's going to be real and imaginary together at last. So a complex number has a real part and an imaginary part, and it's complex because they are not like terms and they cannot be combined, so we call it a complex number. So the standard form of a complex number is A plus BI. And you remember from the last video, BI is how we write imaginary number standard. So A is the real part and BI is the imaginary part, okay? So for adding and subtracting complex numbers, it is just like combining like terms. That's all there is to it. Combine like terms. If they don't match, you can't add them. So let's look at number one. Number one, we have negative 11 plus 3i plus 9 plus 2i. So we're going to take our negative 11 plus 9 is negative 2. And then 3i plus 2i is 5i. And that's all there is to it, just like normal. All right, number two, we have 4 plus 7 plus I minus 5i. And so 4 plus 7 is 11. And then I minus 5i is negative 4i. All right, now here's a fun one where we have a negative. That's going to be super fun. But what we're going to do is we're going to do the associative property. So we're just going to rearrange this into different groupings. So we have 7 minus 2. 7 minus 2. And we're going to keep plus now because I'm putting the minuses inside the parentheses. And because standard form has a plus sign in it. And then we have negative 2i minus 6i. All right, 7 minus 2 is 5, plus negative 2i minus 6i is negative 8i, or you can write 5 minus 8i. Either is acceptable. And finally, number 4 is 6i minus 14 minus I plus 5 minus 3i. So we are going to go ahead and have our negative is going to distribute through. Okay, so we're going to have 6i minus negative I plus negative 3i. And then our whole numbers, our real numbers, we have negative 14 plus 5. All right, so negative 14 plus 5, that's negative 9. And we're doing that part first because it's real. 6 minus negative 1 is going to be 7, plus negative 3 is 4i, right? So adding and subtracting complex numbers is the same as adding and subtracting like terms, nothing to it. All right, multiplying complex numbers, remember, we want to remember that I squared is negative 1. And we are going to be distributing here, okay? So we have 2i times 8. 2 times 8 is 16i. And 2i times negative 3i. 2 times negative 3 is negative 6. I times I is negative 1. Negative 1 times 6 is positive 6. And remember, standard form, the real part comes first. So we're going to have 6 plus 16i. All right, same thing on number 6. Negative I times negative 2. That's going to be 2i. And then negative I times negative, or plus positive 10. So negative 1 times 10 is negative 10. I times I is negative 1. 10 times negative 10 times negative 1 is positive 10. So we have 10 plus 2i. All right, number 7 has a binomial complex number. So it's going to be double distribution the same way we did with polynomials. All right, so first we have 7 times 4 which is 28. And then we have 7 times negative I, which is negative 7I. And then we have I times 4, which is positive 4I. And then we have 7 times, oops, sorry. And then we have I times negative I. So I times negative I is I times negative 1. I times I is negative 1 times negative 1. And that's going to be negative 1 times negative 1 is 1. And now we just need to combine like terms. All right, so 28 and positive 1, that gives me 29. Negative 7i plus 4i is minus 3i. That's all you have to do there. Now, number 10 is a little bit more complicated because we do need, I'm going to skip number 8 and number 9. The only thing I'm going to say about number 9 is if the square throws you off, please just rewrite it. But in an effort to make this video a reasonable length, considering we had such a long one for the first lesson, I'm going to skip to number 10. So let's go ahead and do that. Okay, so we are going to follow PEMDAS on this one because we're not solving. We're trying to combine like terms. So first, parentheses, we can't simplify anything in there. We don't have any exponents, so now we're going to go with multiplication and division. Multiplication is what we have here. So we're going to have 1 times 9, which is 9. 1 times 3i, which is 3i. 7i times 9. 7 times 9 is 63i. And then 7 times 3i. 7 times 3 is 21. I times I is negative 1. 21 times negative 1 is negative 21. And then it's a matter of combining like terms. So we have 9 and negative 21. So we have negative, let's see, what do we have with that? All right, so that's going to be negative 12. 3i plus 63i is going to be plus 69i. And we still have this part up here. So minus 4 plus 2i. And then again, it's going to be distributed 3. So we'll have negative 12 minus 4 and plus 69i minus 2i. All right, 12 minus 4 is 8, plus 69 minus 2 is 67i. So that's how we would multiply them. All right, next we have our complex conjugates. Conjugates are basically, they're going to be multiplied together to get a real number. They will have different signs in the middle. So we have plus here and a minus here, and everything else will be the same. And so the reason it'll be a whole number is because the i's will end up canceling out. It's just like when we had our difference of two squares. So let's go ahead and do this one, and you'll see number 11. So we get 8 times 8, which is 64. And we get 8 times negative I, which is negative 8i. Then we have I times 8, which is positive 8i. And I times negative, negative I times negative positive I. Negative 1 times negative 1 is positive 1. And if you're wondering where I got the original negative 1, it's because of this negative in the second term. And then I times I is negative 1. So negative 1 times negative 1 is positive 1. And then we simplify. Well, negative 8 plus 8 cancels each other out. So we end up with 64 plus 1, which is 65. Easy enough. All right. So let's go ahead and do the next one. 5 times 5 is 25. 5 times 4i is 20i. Negative 4i times 5 is going to be positive 20i. And then negative 4i times positive 4i. Negative 4 times positive 4 is negative 16. I times I is negative 1. And so it's plus 16. You might be noticing a pattern here. 20i and negative 20i will cancel each other out, even if I did write it incorrectly the second time. Sorry about that. So 25 plus 16 41, right? So the last part we're going to do is dividing complex numbers. So dividing complex numbers is exactly the same as dividing radicals, which we didn't actually go over, but the notes are available on the should be available on the Google Classroom. So if we had the square root of 3 over the square root of 2, we don't want a radical in the denominator, and I is just the answer to it's just a radical. So we are going to multiply by a variation of 1 and get the radical out of the denominator, right? So we're going to do square root of 2 over square root of 2, and that's because we want the bottom number to become a whole number. So negative square root of 3 times square root of 2 is square root of 6, and square root of 2 times square root of 2 is 2. So that's how we would get the radical out of the denominator if we were using radicals. But if we're doing imaginary numbers, sometimes you have to do it a little bit differently. So first of all, we've got 10 over 2i. We're going to multiply this by 2i over, sorry, just I over I. We don't have to do 2i over 2i, because it's just the radical. So I over I times 10 is 10i, and then 2i times I is negative 2. And then 10 divided by negative 2 is negative 5. Same thing for 14. We're going to multiply by I over I, if it's a monomial, which this is. So you get 4i, and negative 9 times I squared is 9. And so we get 4 over 9i, or 4i over 9, or 4 over 9 times I. And just make sure if you write it like this, that you use a vertical fraction, not a diagonal fraction. So 4 over 9, the way I have it written here, this is not technically the same as 4 over 9i, the way it's written like this. Make sure you're doing vertical fractions. All right, and then I'm going to skip down to number 18. It said if we have a binomial, then we multiply by the conjugate over the conjugate. So 6 minus 2i over 6 minus 2i. And again, we're going to have 6 times 6, just 36. 2i times negative 2 is negative 4. Times negative 1 is 4. So our denominator will be 40. And then 5i times 6 is 30i. 5i times negative 2i is positive 10. So we have 10 plus 30i over 40. All of these numbers are divisible by 10. So we're going to simplify. We're going to have 1 plus 3i over. So you would do the same thing as you're just going to follow the same rules for multiplication once you're multiplying by the conjugates. You will always do your double distribution if there's two binomials, and your single distribution if it's a monomial times a binomial, but it's going to be the same rules as multiplication. So just make sure you're following those rules. All right, so we're going to wrap this up right here. Again, the rest of these answers are going to be available on Google Classroom for you to see. If you have any questions, make sure you reach out to me. We will be having live chat on Tuesday and Thursday in the Google Hangouts. If you have any questions, that is the most efficient time to get in touch with me because I will be sitting at my computer. Talk to you later. Bye.